in this lesson, they're really trying to hammer home that you guys understand that exponentials and logarithms, that they're inverses of each other. So what does that even mean? So we've gone over that a little bit before. So the idea of inverses is if you just have, let's just say you have your set of, you have your domain and you have your range. And basically these are your x values, these are your y values. So a function takes these and maps them to another value. That's what a function does. What does an inverse do? Well, an inverse does not the opposite of that, just does it backwards. So that's what an inverse function does. It just takes those same values and maps them back the other way. So really, what does it do? It just switches x and y. So let's just say you have the ordered pair, 7, 3. Then the inverse would be 3, 7. And the interesting thing, because we're going to be getting into graphs right now, the interesting thing is that for a graph, it reflects based upon the line y equals x. So let's just say you have something going on over here like this, and this is f. Then the inverse would go like that. So that's the main idea. So this first example doesn't really take that idea too much, but they're just asking to rewrite your logarithms. So this would have log base 10 of 1,000 equals 3, because remember 10 to the third power is 1,000. And this one rewriting, this would be 3 to the fourth power is 81. So this is just all about rewriting it. Nothing to do with this idea, but the next two examples you'll see have everything to do with this switching x and y idea. So here they give us a table. You could read through it, but basically this one represents the exponential. This represents the logarithm. So really they're just switching x and y. They're just inverses of each other. So if you have 1.301 and the output is 20, then notice when the input is 20, the output would be 1.301. Let me pick a different color so you guys can see that I'm answering that. And I'm also going to highlight it. And you could see that. Let's see one that's already answered. 0.699. The output's 5. When the input's 5 of the logarithm, the output's 0.699. So just switching those x and y's. Look right here. When our input is 30, our output's 1.477. So when our input for the exponential is 1.477, then the output would be 30. And that's all that is for that assignment. So it's really not that difficult. Do not get too crazy about that. It's just switch x and y. So if you have the point 1.30120, then the inverse would be 20 and 1.301. Now what about a graph? They give us a graph here, and they give us the log graph, the graph of the log. They want the exponential answer. So what are we going to do? Same thing. So here the point is 0, 1. Oh no, my bad, 1, 0. So our other point will be 0, 1. We're just going to switch those x and y values. Over here, this point is 2, 1. So then our other point would be 1, 2. This point is 4, 2. So our inverse point would be 2, 4. And then we have 8, 3. So the inverted point would be 3, 8. And then our next point is 16, 4. So then our inverted point would be 4/16. Same set of instructions as the last one. We're just doing the inverse. Let me clean up the way that looks. We're just doing the inverse. We're just switching our x and y coordinates. And that's all there is for the assignment. You're just going to either rewrite our log and exponential forms, or you're just going to be switching the x and y values.